So this is a Jamboard that I used last year, but I changed a whole bunch of stuff. Okay. Words for end behavior. Well, if we're going this way, this is X. Let's see. Can I write on this? How does this go? You guys could write on this too, but this is the X. Yeah, that's not a very good one. Let's try this one. This is the X, and it is going towards what, if I want to go that way? Infinity, and that would be the word for going right. Okay, anybody want to fill in any of the rest? You guys should have access. You can use the little text box tool here. You could use the sticky note here, or you can use your finger and the one of these guys up here. How many of you have never done a Jamboard before? Anybody? Oh, lots. These were my students' favorites last year because they like to be able to write on here. But like you could click on this text box and then you would be able to type. Wow, I've never seen that before. You would be able to type in here like what you wanted. You could use for infinity, you could say y to infinity if you wanted. What are the words that go with the end behaviors? So if you're going this way, X is going towards negative infinity, and that's left. Y to infinity is up. Good job. Positive infinity up. Good job, good job, good job. Okay, and when we write this one, we actually write it in the order X approaches negative infinity, right? All right, some of you are doing grand for your first try. Some of you have maybe done this before. It's not super easy. All right, great job. Okay, nice participation. This one I would like some drawings in the little boxes here. Like, how about we try to split these down the middle? We'll do 2 drawings per box. So see if you stay away from someone else's drawing. But this end behavior says what? Let's discuss this first one here. What is the word here, guys? X approaches infinity would be right and up, yes? And then left and up. So I need a couple drawings where both ends are up. And then pick a different one. Okay, that looks good. We have lots of the same idea. Okay. What about the next one? Try all of them, guys. Fill one in. What you think? Good job. The next one has both the y's negative, so that would be both ends down. Ooh, let's see what's happening at the bottom. Ooh, we got opposite opinions on the last one. Which one is right? We won't talk about whose is whose, but let's see. On the last one, it says on the right, it goes what? Right here. On the right, it goes down. And on the left, it goes up. So which one is correct? The black one or the yellow one there? What did it say? Okay, you're good. I was trying to figure out which one it was again. It was on the right down. Yes, so this one was correct. Okay. And then this, wait a minute. This one, I have both ends down. This does not say both ends down. Look, there's the Y right there. This one says on the right up. So this one was correct. Someone tried. That is correct. There we go. That's looking better. Everybody good? Can you read those? All right. Right end behavior statements for each. How about if I assign this to somebody? Ben, which one do you want? 1, 2, 3, or 4? Okay, you try 2. Raina, you want 1? Which one? Okay. Okay. You can't write on the bottom? Oh, somebody moved it. Let me see. Can I make it smaller? Okay. I don't know who moved, but thank you. Okay. Somebody want 1? Okay, Jada, anybody want 4? Thinks they can do this with their finger? Antoine, do you want to tell me what to write? Can you tell me 4, Antoine? Do you want me to do X? I want just the end behavior statement, so however that works for you. Yep, whatever people are doing is looking good so far. Do you want to say X or Y first? Okay, you want to say left or right first? So that would be what? Left would be X is negative, right? And what is it doing on the left? This one? The left is this side. It's going up, right? Are you one of those left and right is confusing people that I'm not helping? But this whole lesson is confusing, huh? This is left, this is right. So on the left, it's approaching negative infinity from X, but positive infinity for the Y values, okay? So on the right, what do we say? Let's see, X is going to the right would be positive infinity, right? That means we're going this way. But the Y values are going down, so we'd have negative infinity. Okay? You all right? You're correct. Let's see what we have up here. Oh, somebody typed. Y approaches negative infinity as X approaches infinity. What's that talking about? Which side, guys? The right, because it says X approaches infinity. And then it says Y approaches infinity, negative infinity still, yep. As X approaches negative infinity, that's saying both ends are down. Good job. X goes left, it's up. X goes right, it's up. Nicely done. X goes right, it's up. X goes left, it's down, because these are both negative. Great job writing, guys. I am cheating because I have my little pen. Okay. All right, last ones here. Can you see it on your Chromebook better? This is actually a calculus kind of question. It's in limits, but if you saw this, could you figure out what it's saying? What is a degree 4 with a positive exponent going to look like? Yeah, both ends are going to be up. So then we need the f of x's to both be what? Positive. Yeah, that seems like A, right? F of x. So even though this is in limit notation, the f of x, yep, somebody can put a big check there for us or something. And then this one is a odd power with a positive exponent. So it actually would look like this if you typed it in your calculator. So let's see, what do they start? They start with the y's, right? What are we circling? The bottom one? This would say left, down, and this would say right, up. That seems good. Somebody was speedy. Okay. What does this mean, guys? I don't know if I put the yellow, if it'll show. Odd means what? Odd means, odd, oh, this is symmetry review. So this is a bad, this, Yeah, very confusing. You're right. Odd function. There we go. What does it mean to be an odd function? Why can't I hit? Yeah, that's what I meant. Function. Oh, that's not a good word. Let me fix that. Okay. Odd function means what? Which of those? Somebody drag one of those sticky notes over. So which of those sticky notes means odd means origin symmetry and even means y-axis symmetry? We good? Okay. So let's go to the next slide and see what's happening here. For all of them? Yeah, all of these have origin symmetry, so these would all be examples of, there's Hofbauer without her pen writing odd, okay? What about these guys? This one is a little confusing because, let's see, they went a little further, right? With one side than the other. But it is folding across, so these are all even. Good job, people are writing. Oh, I like the blue on there. All right, I'm gonna go to this one. Again, they have some examples, odd, even, neither. Are we clear on what neither would be? All right. So, fill these in. Odd, even, neither. You can use the text box. You can try to write. You can, make a sticky note. I think you can duplicate your sticky note and move it somewhere else. Neither, good choice on that one because it's not going through the origin. Second one is even. Next one is even. 4 is odd. You're all over it, guys. 5 is odd. And 6 is neither. Whew. And what grade are we in? Doesn't it look like a second grader? Oh, all right. Now we're going to talk about increasing and decreasing. What values would we need first if I asked you to give intervals for increasing and decreasing? What would you have to find first? Yes, the maxes and mins. So if I go ahead and put, let me use something. If I put an ordered pair here and call it 1, 2, negative 2.8, comma, positive 2.8, I don't know. And I call this one, I'm going to be lazy and just call that one 1, negative 2.5. Which of those values do we need when we do increasing and decreasing? You only use the x values, okay? So do you need me to review this first? The important thing is we go left to right, yes? Okay, so from here to here, this graph is doing what? Increasing. Even though the arrow points down there, the graph, the values of the function are increasing as we go left to right. So that was coming from the left until negative 2.8. It was increasing. Is there somewhere else that it's increasing? From 1 off to the right. So it's also increasing from 1 to infinity on the right. All right, if I were to do green, it is decreasing in here from negative 2.8 to positive 1. Everybody okay? All right, so let me throw some number. Can I just make up really nice numbers to make life easier on us? I'm going to pretend this is negative 4, 5. I'm going to pretend this is negative 1, 2. I'm going to pretend this is 0, 3. And I'm going to pretend this is 2, negative 3. Okay, so I'll put over here, you can write the increasing intervals, and over here you can write the decreasing intervals. Can you fit some in there, underneath there? Or type them? Oh, this is not going to go well, is it? Okay, I see lots of negative infinity to negative 4s over here. That does seem increasing. Good job. -1 to 0, someone put, that is increasing as well. And then someone down here has 2 to infinity. That would be increasing. Okay, quickly these 0 to 2 moved over there. -4 to -1. 0 to 2 decreasing. -4 to -1 decreasing. Everything I see looks right. Anybody have a question? All right, and then finally, concavity. This is what we did yesterday. What point do you need to be able to do concavity? You need the inflection point, and I will give you the inflection point on the quiz. So let me, yeah, that looks like a good choice. Let's call that, 0.5, 0. So 0.50, we'll call that the inflection point. So where is it concave up? Which side of that is it concave up like a cup? Okay, people are writing it. It would be this side over here. So we could say from 0.5 to infinity. Good job. Got lots of people writing that. And then which side is it concave down? How do you explain that it's that side? Anybody want to just tell me? Oh, somebody's writing it well. Yes, negative infinity to the 0.5 at the top. Good job. Okay, I'm not sure this is going to be worth going back and looking at later because I think you'd be really confused. But all right, I'm going to pick some people so we don't have quite so much confusion. Cheyenne, can you pick, what do you want to do, an increasing or a decreasing? Okay, find an increasing and those are inflection points, okay? So we're gonna, oh, that means we're doing concavity. Thank you, brain. Cheyenne, you want to do concave up or concave down? You do concave up. Who wants concave down? Okay, Jada, you do concave down. There's a couple intervals for each, but we'll just let one person do each so we don't have so much confusion. Are we writing some intervals? Negative, ooh, somebody typed, okay, negative infinity to 2 seems down, right? Everybody agreeing that that piece is going down? And then it says 5 to 8 is also down. And this is looking good. 2 to 5 would be up. Right here. And then I think that's supposed to be up as well. I'll help you here. We'll call that an 8. I didn't, okay, you can fix it. I'm sorry, I'm messing up after I asked you to do it. Yes. So when I tried, I made it worse. I'm not very patient. That's my problem. And technology is, good job. Everybody okay? What do we got? Are we done? I think we're done. Okay. Chromebooks away, worksheet out, please, because we're going to do this quickly. And then you have a Delta math maybe to do today? I don't know. What is the assignment today? It is a delta math? What is it called? 1.4b? Okay, that's what I thought. Yesterday we did a worksheet instead of, okay, I got it. I'll be okay. What worksheet is this, guys? 6b? Okay. All right, so this is the graph. It's kind of crazy. So it's, we're supposed to do, I think, yes or no for the first few here. Is the function increasing between -4 and -3? As I go left to right from x equals -4 to x equals -3, it is going up, so this is a yes. All right. Is the function increasing from 1 to 2? 1 to 2 would be that piece right there, and it was going down as I went left to right. Is everybody with me? Did you find the worksheet? You good, Antoine? Okay. C says, is f only increasing over the interval from -5 to -4? -5 to -4, is it increasing? -5 to -4, it's decreasing, right? Is the function decreasing from -3 to 1? -3 to +1. Anybody know what that's called? It would be constant there. Good job. Is it decreasing from 1 to 2? Yes, it is. 1 to 2 was decreasing. Everybody got what they want? Because I'm have to put a new slide here. Is that the next one? Are we on F already? Okay. List the intervals over which it's increasing. Well, okay, we thought we got this started. Increasing. Anybody give me the furthest left one? -5.5 to -5. This one's increasing. Where's the next increasing? -4 to -3. And the next increasing? Yeah, the far right piece here would be 2 to infinity. All right. Decreasing. -5 to -4. It went down, and 1 to 2. And the constant would be -3 to 1. All right. X-intercepts, anybody? We can just list them. -5, you could write it as an ordered pair, I don't care. Yep, -3.250 and 20. Can we figure out the y-intercept? What's the y value staying at right there? 2.5. Can I go on? Is there a local maximum at -3? That's not a question I would ask you. I don't remember what Ms. Gupta, I asked Ms. Gupta that question last year, if that's considered a max or not. I'm just going to go with, we're not going to answer that question. Is there a local minimum at -4? Local minimum right here? Yes. Is there an absolute minimum on this graph, guys? This one, right? All right, list all of the graph's minimums as ordered pairs. All right, so negative 5.5, negative 2.5 is an absolute minimum. There's a relative minimum at negative, oops, messed that up already. Negative 4, negative 2. Any other minimums that we're pretty confident is a minimum? 2, 0. Antoine, you okay? Yes. Yes, it says, yep, that's a great question. I actually like local, the idea of local better. It means in this local area, is that the lowest? And that's why I'm not so sure that that works or not. I can't remember what she told me. If I looked up, I could find it, but list all of the graph's maximums as ordered pairs. Well, again, I'm not sure if we're supposed to count those, but where is there clearly one maximum? Negative 5, 0. I don't have a constant place on the graph for you guys on the quiz. Is there an absolute max? No absolute max for sure, right? Because it has an arrow on the right. All right. Okay, this goes back to last week. What is f of negative 5? When you put in a negative 5, what do you get out of this function? 0. That's this point right here. Negative 5, 0. F of 1, 2.5. Now, does anyone know what this is asking? F of x means what? That means when y is negative 2.5. So do they give us anything when y is negative 2.5? When the y is negative 2.5, the only place the y value hits negative 2.5 is at negative 5.5. When it says f of x, that wants y. So when y is 0, well, there's 3 points that have a y value of 0, right? All right, that's not on this quiz. Some of you need to retake that idea, but all right, what is the domain? It is not all real numbers. Furthest left this thing goes. Negative 5.5 to furthest left, x value off to the right. All right, range is bottom to top. This was x's, this is y's. The lowest y value is negative 2.5, and it had a dot there, but it's going up forever. That is on the quiz again, domain and range. All right. This is 7A, yes? Okay. X-intercepts, can you estimate them real quick? You could list them like that, or you could write ordered pairs. I was not picky on the quiz. Anybody want to say where they think that y-intercept is? Negative 4.5. Domain, if that's a solid dot, what's the domain right here, guys? Left to right? Is the next question range? I'm just going to write it here so that you can get caught up if you need to. What's bottom to top? It has nothing to do with this point. Remember, it's the very bottom, so it's, and we said it had an intercept there, so it's negative 4.5 and up. Y values. Remember that y value from right there. Oh, I don't even have range. I cut it off somehow. All right, increasing. What do you need before you can do increasing and decreasing? The maxes and mins. I'm going to be lazy and call this -4, 6. Is that okay? Even though it's not. That would be a max. And I will call this min 0, -4, just to make our life easier. Okay. If you use decimals, it's fine. Where is it increasing? Somebody give me one interval. Okay, this piece is from -6 to -4. And remember, increasing and decreasing, you don't have to worry about brackets. It's just all parentheses. Where's the other spot it's increasing? Be careful. I need x values. So what is the x value at that spot? 0 and to the right. And it was decreasing in between those two, which were x values of roughly -4 to 0. Can I erase the scribbles I drew on the picture at least, so that we can talk about the next part? How many points of inflection does this have? Just one, because between a maximum and minimum, it should have a point of inflection somewhere. Can I just pick -2, 0 to be the point of inflection? On the quiz, I tell you what the point I want you to use is. Okay, you don't have to try to figure that out. All right, so which side of that is it concave up? This right side, and remember you use the x value, so it is from x equals -2 off to the right that it is concave up. And normally, if this had an arrow, we'd say -infinity to -2. I suppose here we're supposed to say -6 to -2. The ones I give you have arrows. Even, odd, or neither. Does that have any symmetry? No. Is that it for that question? Even, odd, or neither for this one? Neither, even though it's kind of close to looking like y-axis, neither. You want to try these on your own? Give you 2 minutes to do as many as you can. Allo, do you have domain and range? What do you have? Good job, because left to right, it's going further both ways. And the range? Yeah, it's kind of hard to tell exactly how low it goes, but I would have said -8 as well. And then it's going up. Everybody good on those? You poor thing. Sounds like you have a cold and then a mask. Miserable. Any questions on those first four before I go to the next slide? Everybody checking their answers? Any questions? Remember, its bottom y value here was -8. And everybody got 4 x-intercepts, right? All right. And then, oh, we needed, I don't know why I don't have this listed in a better order. What did anybody put for a min? Okay. And the other min? Okay. We can be lazy and call it 4 -8. I don't know if it's exact, but we'll be good. And if you used a different decimal, it's fine. And the max? Like -1, 7.5. Anybody okay with that? All right. Which of those numbers do we care about when we go to do increasing and decreasing? Only the x values. So this was -4.5, this we called -1, and this we called +4. So increasing was this piece and this piece. So -4.5 to -1, and 4 off to the right. How we doing? I see you racing. Because remember, it says you go left to right. Left to right, okay? And decreasing would be, let's see, this first piece is decreasing. So that's -infinity to -4.5. And then it's decreasing from -1 to 4. Did some of you have that right? I think on the quiz I'm smart and I ask for max and min first, okay? That will help. But you do have to use whatever crazy numbers your calculator gives you for max and min on the quiz. Because you have to actually find them with a polynomial, not a graph. Okay. Inflection point, I'm just going to use these right here. Does that seem okay? So what did we call that? -3 and +1? -3 and +1 as the places it switches. Those you could have estimated. Whatever you had was fine if you did this. So concave up, where? To the left of that and to the right of that. So from -infinity to -3, and again from 1 to the right. And then the piece in between was concave down. We said neither. Both ends are doing what? Up. So both of the y's should be +infinity here. Questions? Okay. It said in the notes that we were going to do the next page. Let's just wait and do that Monday. Okay? So that we revisit this once more before the quiz. Does that make sense? So no worksheet homework. It's just 1.4b. Delta Math 1.4b. And I don't remember what it's called. More graph analysis would be my guess. Delta Math. Okay. A whole bunch of you have been keeping up with your Delta Math really good, and then there's a few people who it's 0.00000%. That's not going to make the